Thanks for joining us for another episode of DPC Radio. This episode was recorded live in Amsterdam at the Dutch PHP Conference 2012. For more information about the Dutch PHP Conference, visit our website, phpconference.nl.
Wow, I'm impressed to see so many people after this awesome social. Are you awake? Can you follow me? We'll see. Okay. You'll see a lot of code today. I will upload the slides, so if you can't follow me, you'll at least can, at the end, recap when you're at home or at work next week. So welcome to the talk, The State of DI. Let me introduce myself. My name is Stephan Hochdörfer. Judging from my last name, I'm from Germany. I live there, I work there, running my own company there. The company is called BitExpert. We are focused mostly on web development, consultancy, stuff like that. We founded the company in 2003 and changed the structure of the company in 2007. From that day on, I'm responsible for managing our research labs department, which basically means that I'm the one in charge of any technology-based decision concerning our customer projects, our internal projects, our products that we develop. I'm a long-time PHP guy. I started in 1999. We did a hell lot of DI projects, so I've experienced over 7 years in doing DI projects. We did roughly a couple of hundreds in the last 7 years. Yeah, if you have any questions, this is my email address, this is my Twitter account, we'll be here the full day. Any one of you does not know what the acronym DI stands for? Okay, awesome. DI means Dependency Injection. Now dependencies, what are dependencies? The definition that Wikipedia comes up with, that a dependency is any logical or physical object upon which your own code depends for its proper execution. Now this is quite high level, right? So this basically means that the Apache web server might be a dependency because you need the Apache to run a website. PHP is a dependency because if you've written code in PHP, you need the PHP interpreter to run your code. But it also means any framework or any PHP library that your code uses or that your code needs to be able to execute. So are dependencies bad? What you are thinking? No, right, not at all. Well, that's probably a bit too harsh. Dependencies are not bad at all, but hard-coded dependencies are bad, right? Because if you're dealing with hard-coded dependencies, you can't exchange them, especially when you're testing. Hard-coded dependencies actually lead to tightly coupled code. Now, tight coupling might be good in different areas in your life, but not really for the software development part. Because tightly coupled code means that you cannot really reuse these different components, not in just the project you're dealing with, but also in the other projects that you might be working on. If you can't reuse components, that basically means that you can't isolate them. And if you cannot isolate a single component, that really means it's not testable. And that leads us to dependency manners. So you're dealing with this big ball of mud of application. You're not able to break the system or the application into small modules that you can manage independently or reuse in other projects. So that can really drive you crazy. I'll give you a really quick, short introduction of DI because the main focus is showing you how DI works in different frameworks. So just to get you on the same level. So what's DI about? Basically, it's this, and I guess most of you have done code like that, right? So it's injecting a dependency into an object on its construction time. In this case, our talk service requires something that we call a talk repository. Anytime we create a new instance of the talk service, we have to supply the dependency so that the talk service can work accordingly. Now, in DI, we are dealing with three main opponents. We have consumer objects. These are objects that accept dependencies. We are having our dependencies, which can be consumers as well. And we have something, and this is the part that we will focus on today, that we name the container. The container is responsible for creating and configuring the consumer objects and returning them to the callee. Now, in the perfect world, if you pick a really good framework, your application code does not really matter how the container could look like. You can easily exchange it. As long as it will return the right objects in the correct configured way, everything looks fine. So let's step back a bit. a bit of recap, a bit of history. How old do you think the pattern of dependency injection is? Would you think that dependency injection is roughly 5 years old? How many think that? Just going to raise your hand. No one. Awesome. 10 years? 1, 2, okay. 15 years? A few more hands up. 2,000 years? Yeah, roughly. Almost. Well, the first paper actually was published in 1988, which is quite some long time. So basically, in the measurement of IT, it probably is 2,000 years. It was published by, or it appeared first in a paper that was called Designing Reusable Classes by two guys, Ralph E. Johnson and Brian Foote. Well, actually, to be precise, it was not really called dependency injection in those days. They were referring to a pattern of inversion of control, which is the overall stuff that dependency injection deals with. Then some years went by, and Uncle Bob published an article, The Dependency Inversion Principle, which again focuses on that stuff. And from that day on, at least in the Java world, it took a bit off. The Spring guys wrote their framework, Google Juice came up. There's some other small containers that really get hooked off. But it really got famous in 2004 when Martin Fowler published his paper, The Inversion of Control Containers and the Dependency Injection Pattern. I guess this is the most quoted article among all the different frameworks that deal with dependency injection. If you're using a dependency injection framework which does not refer to this article, you're just going to drop it because it can't be true. Now we're stepping back to the PHP world. The first PHP container was published in 2005, 2006. It was called Garden. It was a really lightweight container that was loosely based on the Spring framework. So they had an XML file where the dependencies were declared, and Garden, the library, would read from that and create the objects. Well, unfortunately, this was not really ready for production. It was more like a proof of concept. The first real framework offering DI support was released in 2006. It was called Stubbles. Anyone is aware of that? No? Okay. So this was published by one of the largest ISPs in Germany. It was inspired by Google Juice, and these guys put a whole framework around that stack. The basic idea was that the Java guys working at this ISP could also write PHP code because it was quite similar. The first references concerning talks and sessions at conferences appeared in 2007. There was in Germany the International PHP Conference, and there were two talks. One about Stubbles, the other one was by a guy called Robert Lemke. Those of you who have attended the workshop or his talk yesterday on Flow 3 might recognize him. This was actually the first public appearance of Flow 3 at a conference, so he showed off the stuff that they were doing. And I have to honestly say, he really blew off my mind when he showed the stuff that they were doing. And when he told me that they would release a version roughly half a year after the talk, I was really impressed. Now, unfortunately, it took some more time till they get the final version done, namely last year. So they did a lot of rework of all these modules and stuff, but it's really great tool. So in 2011, it was really the year of DI in PHP, I guess. So we had Zen Framework 2, actually the beta version, which offers DI support. Symfony 2, which came out with DI support, and as I said, Flow 3. So let's have a look. Yeah. When you're looking at the different implementations in PHP, you have the choice between two ways. You can actually use a simple container or a full stack DI framework. Now, with simple container, I mean these really small libraries that you can easily drop into your project. They offer some basic support. While with a full stack framework, I just mean the whole framework is aware of this DI approach, and every single piece and every single working of the framework can be configured using DI. So I personally would always try to go for the full stacked one and use the current frameworks like Symfony 2 or Flow 3. If you can't do that and you want to add DI support later to your project, you probably are best using one of the simple containers. And that's what we start with. Now comes the code part. One of the simple containers that was published is called Pimple, which is brought to life by Fabienne, the lead guy behind the Symfony project. It was published in 2009 and looks like this. So let's imagine we have a class called TorqueService, which has a constructor and a method getTorques. It's quite easy to set that up in Pimple. You're just going to require a class. You require the Pimple container. You create an instance of that container. And then you register a closer function which simply returns this service. And I can access this container and just simply by the array notation and just going to grab the instance from that. It's quite easy, quite simple. Pimple also supports constructor injection. Let's say we have our talk service. The talk service has a constructor that needs a repository, which is defined above and implements an interface. It's quite easy to do that in Pimple as well. Requires a bit more of code, right? So we first would define the talk repository, the dependency that you actually want to use. And then below in the talk service, we're just going to grab the $C variable and pull off the $C variable is actually the reference to the container again, right? And we grab the dependency from there, inject it manually in the talk service, and return that again. So as you can see, you have to write a lot of code and do all this wiring manually, which probably works in a small scale, but it can really suck if you try to do it on a big scale in a huge application, right? Because you have to write a lot of code. Pimple, on the other hand, also supports setter injection, because as I said, it's really a lot of manual work that you have to do. Let's say we want to add a logger. We just define the dependency again using this anonymous function and returning the logger instance. And you can see below in the talk service, we have the call to the setLogger method, which again just going to pulls the logger instance from the container and just injects it manually and going to returns it. Any questions so far? Awesome, that's simple. Okay, some general guidelines. Normally, if you would call or if you would grab the logger from the Pimple container, you would always get a new instance back from the container, which may or may not be a good idea. Let's say if you have your database connection stored in there, you don't want to get a new database connection on every pull from the container, right? Because let's say you want to use a transaction-based model. You don't want to get 10 connections with 10 different transactions, because otherwise you end up in mess when you do the rollback. So we need a way to say, I want some kind of shared instance, right? I have something in the container and I want to retrieve every time I try to access this logger, the same instance back. And this is what we do in the logger shared definition. We wrap this anonymous function in the share method, and thus Pimple would know that it creates the object on the first time, and when you access it later on, you will get the same instance back. This is the basic idea. Now, Pimple is one of the simple containers. There's another one called Bucket. Bucket was also founded in 2009 by a Danish guy called Troels Naknissen. And it's also just some simple piece that you can drop in your application code and make use of dependency injection quite easily. Again, we have our talk service with a constructor, with a talk repository that it's needed. To use that or to set that up in Bucket, it's quite easy. Again, you have to require the file, set up the Bucket container, and all you have to do is say container create talk service. And Bucket internally uses some kind of reflection logic, which would then figure out that the talk service needs the talk repository. It would check how to create the talk repository, create this instance, and feed the dependency in the talk service on construction time and just going to return the object. So there is no need for you to write really that much of code. It just magically works. Bucket decides between two ways of accessing these instances. So anytime you call the create method, you get a new object created. If you call the get method, you get this shared instance. So the first time it would create a new one, and any time afterwards you call the get, you get the shared instance. So these are the simple ones. As I said, really easy to use. if you want to extend an existing application with a DI pattern because you want to make the application more testable, that might be a suitable way to go. If you are in a good position and start a new project, you might want to have a look at the full stack frameworks, which I'll cover up to, in the next couple of slides. So I'll start with the send one, or send two, actually, to be precise. Again, we have our talk service, constructor, and a getTalks method. And it's quite easy to feed that in the DI container of Send. All you have to do is create an instance of send DI and just call the get method with a class name. And then, oh, sorry for that. So you call the get method with the class name, and it uses reflection to have a look at what it's needed to create this object, configure it, all that stuff, and return the object, and so you can work with it, and you can call the getTalks method. It's quite simple. SendDI also supports constructor injection. Again, a similar example as below. We have our talk service that requires a talk repository. To do constructor injection, it's exactly the same code. So SendDI would examine the Acme talk service. It would detect that it needs the repository, would then check what dependencies are needed for the repository to be created correctly, and then feed in that instance to the talk service, and it would be returned. We have also support for setter injection. Like in this case, again, we want to set our logger as an optional dependency. Now, this is a bit tricky in SendDI. This requires really a bit of code. It looks like this. Let's step through it. So since setter injection is a manual one, we have to tell the SendDI container that it should inject this optional dependency on this object on the creation time. So yeah, we set the configure method. We have to provide a configuration object which contains a definition where we say for the class Acme service, setLogger is a required method that needs to be called. Now, this was a bit confusing to me, actually. In the first place, when I tried it, I passed the object of the logger as a parameter to require. I did not set it to true, which absolutely failed and just got some weird errors. So all you need to do is actually say that this is a required method that needs to be called, and SendDI will then call it. And thus, if we create the instance of the talk service, the logger would get injected, and you could use it in your code. There is an easier way to get around that, and it's called interface injection. In interface injection, we define a global interface. In this case, it's called logger aware. You have to be aware that the aware part is quite important because this is the trigger for the SendDI framework to recognize this as an interface, that it's important and that gets executed. We define a method there, setLogger. We implement the interface in our talk service, which exactly looks the same as before, but we have just the implementation part notated next to the class. And this triggers a mechanism in the SendDI framework which will automatically inject the logger dependency to the talk service. So we don't have to write any code at all. We just call that stuff and it works. And now some general usage overview. As I said before, it's quite easy to get an instance. We call just the get method on the talk service, and SendDI will do the rest magically, examining all that stuff via reflection and returning the correctly configured instance. If you call get the second time, it will return the same shared instance as before. If we want to force to get a new instance, we could either pass a custom parameter to the get function. Like in this case, we could say there is a repo parameter in the constructor. Let's go back if you can see that. Yeah, you see the talk repository is actually called $repo. And what I do now is I say, I want this variable to be filled with the talk repository that I just provided with this instance. And thus, we obviously get a new instance of this configuration object because that parameter might differ from the previous ones. You also get a new instance if you force it. There's a method, I think it's called new instance, which would again generate a new instance of the requested object. Now, I don't think this is really good design because the caller should never ever be able to do that. Because as I said before with the database example, you don't want different modules in your application to get access to different database connections, so that at the end when you try to roll back a transaction, you really get fucked up because you're dealing with actual multiple connections to the database. The callee should never ever be able to decide that. It should be part of the logic of the container to decide if you get a shared instance or if you get a new one on every query. Now, all the examples I showed you up to now use the reflection API to figure out what's going on. On a production server, I would not really recommend that because it can get quite slow, and it really does not make sense because your code in production does not change, right? So once deployed, it will run for at least up to the next update. We're looking for a way to do this manually. And this can really freak you out if you have to write the code manually, because it's quite a hell lot of code. Let's step through it. So first of all, we create a new dependency definition, which says we have this PHP class by the name acme/talk repository. The talk repository is one dependency we are dealing with. Then we're setting up our talk service the exact same way. Now, since we want to inject the repository in the talk service, we need to define that. There we need an injection method. We set the name of the method and add the reference to the already created instance of the talk repository, and simply add this injection method to the talk service definition. This also really freaked me out because the class name is called injection method. When I tried to play around with it, I was looking for something that is called injection or constructor injection or something like that. They don't have that. More or less it makes sense. I mean, the constructor is a method, which you could call, okay, you can argue it's a special method, but yeah, it was not easy to figure out that you have to use the injection method one. Anyway, so you have these classes or this builder definition that you add to the builder definition file or the builder definition object. So the container is aware of these configurations. Then you take this builder, hook it into a definition list, and hook that definition list into the sendDI container. And then you could call, as before, acme/talk service, and you get the configured instance. This is a hell lot of code to write, and I probably think that this is not really the way to go. So the send guys once had a script that was able to inspect all the classes that your application is dealing with and create that script on the fly. Unfortunately, due to the many refactorings, they got rid of the script. So currently, I think you have to do it manually. I hope they will add the script later on, because otherwise I don't think this is much of a big use. Any questions so far? Everything clear? Awesome. Okay, so that was the send part. Let's go one step further and check what Symfony is doing. Symfony 2, to be precise. So in Symfony 2, we define our controller class. We have our index action, and in that action we can call the service locator to grab an instance of acme.talk.service. This is the preferred way in Symfony to use the service locator pattern in your controllers and use the I would say normal definition, normal dependency injection rules for everything that's coming later. You could configure your controllers also with a services configuration part, but actually this is the preferred way of the Symfony guys. So what you need next is a configuration file. in the example, I use the XML one because I think it's a bit easier to get and to spot. You could use the YAML one or the PHP one as well. What's really cool is that you can include in the XML one a YAML file or a PHP file, and the Symfony container will at the end merge everything together, so you're really free whatever way you prefer to use as a configuration language. I would go for the XML part because it's quite easy for an XML editor to understand that. Luckily, the Symfony guys have the schema files added, so you get code completion in a default XML editor, which can really help to understand the structure. Unfortunately, they're missing the configuration, the documentation parts. So at least you know which attributes are there and which XML tags are there, but you have really not that much of a clue what's the outcome if you specify such an attribute. So you have to check the reference documentation on their website. But I'm sure they will add that later on. It looks. I'll show you the same example as before, but just the XML part. It looks quite easy, actually. If you remember, we have this talk repository, which is the dependency. We define it as a service, the service with the ID acme.talk.repo, and we just specify the class name. And then we define the acme.talk.service, again with the talk service class, and pass to that the talk repository as an argument of the type service. So if I would create an instance, or if I would request the instance of acme.talk.service, it would in the background create an instance of the repo above and inject that to the service. It's quite easy. So this is constructor injection. Setter injection looks quite similar. So you have a call element in the XML description, where you just define the name of the method that should be called, and beneath it you list all the arguments that you want to pass to it. Now, I really like the consistency of the constructor argument and the setter argument, so you don't have to fiddle out where you are and which exact notion to use. It can happen, as in Symfony, you have these different bundles, these different modules. If you throw them together and refer to services from different bundles, it could be that they do not exist in your actual configuration. So you can pass an onInvalid equals ignore argument to the argument, and thus if, in this case, the acme.talk.logger service would not be available, it would just going to skip that. So you don't get any errors. So the injection would just simply not happen. Symfony 2 also supports property injection. So it just say property name, talk repository, and then pass the reference to the other service you want to inject. So I'd call this the lazy man's method for doing dependency injection. I would not really recommend this. I would always go for constructor or setter injection because of a simple habit, I would call it. If you use constructor or setter injection, you can see it in the doc block comments, right? So it's a public function that hopefully you have documented, so you know exactly which dependencies are there and which dependencies I can set. If you directly want to access a property, it's not really visible from the outside that this is a property holding a different service that needs to be injected, right? So you have to document it explicitly somewhere. And unfortunately, without reflection, you cannot set the property from the outside unless it's a public property, which is also not the best way to solve that. So it really does not make sense to use property injection unless you really care about not writing a setter method with 3 or 4 or 5 lines. So I would always go for the setter injection just to make things also, let's say, more testable or more portable to other frameworks, or other frameworks I would call it, because I can grab this object, right? I could use it anywhere else, like on the command line in a small script. I can supply my dependencies manually, and it will just work. If I use property injection, that might not be the case, so I have to fiddle around with that. So that's really evil. Interface injection. Well, unfortunately, this is not supported anymore by the Symfony 2 framework. they had support in it and just removed it for some parts that I do not really understand. So they had a few problems resolving these interfaces or dealing with multiple methods in an interface and not really wanting that each of the methods of the interface is really an inject method. So they dropped that, unfortunately, but yeah, I don't think that's not a big deal. What I really like is public-private services. A public service is a service that you are able to consume from the outside, while a private one would just going to live in the container. Like in this case, we have our logger defined on top, and we say public is false. That just simply means that I cannot access the logger from the outside. I cannot request acme.talk.logger from the container. I would just get nothing back. All I can do with that is refer to it in the different other services of the configuration file. So internally, the logger is known, but I cannot access it publicly, which again perfectly makes sense if you would deal with a database connection. You don't want people to consume it. You just want to use it internally. So we also have the possibility to inherit the different services. Like, let's say, you need multiple instances of one class, but with different configurations, and you're too lazy to copy the configuration part that is equal. So all you do is take the part that is most common, move it out, and mark it as abstract, so you can't access that from the outside, and just say the acme.talk.service or the acme.talk.service2 has a parent, and Symfony will merge this information and return the object configured, and looking at that as a whole, let's say, and return the correctly configured object. Well, this is really cool. We use that stuff a lot. It makes really sense if you're dealing with multiple, let's say, web service connections or whatever that just need a simple minor change somewhere, and it really makes sense to extract the most common functionality just to reduce the configuration overhead. Service scoping. You can decide if you want the instance to be of the type prototype, which would mean that on every request to the acme.talk service you get a new instance, or if you set it to container, you would get the shared instance one. I don't think that they would support something like session sharing, but I'm not really sure. So that's it for Symfony 2. Any questions? Awesome. So let's have a look at Flow 3. Who of you attended the workshop or the session yesterday? Okay, quite a few. So you can check if I do everything that's right. So Flow 3 is a framework by the guys of the Typo3 project. A couple of years ago, they decided that, I'm not sure if this is publicly recorded, but they decided that their current implementation is crap, and they would start from scratch again. And the idea was to find something that they can base their new products on. And since most of the frameworks back at the time were not quite what the guys expected, they have thought of writing their own ones. And Flow 3 is actually one of the outcomes, which will be the base of the future CMS version of Typo3, or whatever it's called. So Flow 3 supports these different types like Constructor Injection and Setter Injection as well, but does it a bit differently. With that I mean you probably don't need any kind of configuration file. It's all done in the code in most cases. What you have to do is, in this case you see our talk service, it's annotated with @var and then a type, and then it's referred to in the constructor as well. Flow 3 just examines all that stuff and generates some kind of proxy classes, I would call it, which would do all the injection part. So it's all done in the code. You don't need any configuration file. So when the class is the class is instantiated, it would see that there is a constructor in it which has a method parameter, talk service. It would then create the instance and feed it to the constructor, and then everything would work fine. Now, setter injection is also supported. So what you have to do is actually provide a setter method, which again has the type hint. So type hints are really important in this case because otherwise you do not know which kind of objects you have to instantiate and to inject. So you have this type hint of the talk service there. And since setter injection is a manual one, you in this case need to manually tell Flow3 to actually execute the method. You do that by providing a separate file, a configuration file, where you just name the class and say there is a property called talk service, and that needs an object. There is a class named standard controller, and it has a property named talk service, which needs an instance of the talk service object. And thus Flow3, when generating all these files, will note that and inject it respectfully. If you don't want to write that configuration file, the Flow3 guys have added some kind of way of doing that easily by providing a new kind of method that they call inject. So if you have a method in your class that it's prefixed with inject, it gets automatically called by Flow3 when the class is instantiated. In this case, the inject method is called inject talk service. And so Flow3 would call that method, see that a talk service object is needed. It would get that, feed that in, and then your code's fine. It doesn't really matter how you name your method. You could also name the method inject something else. So the name of the method doesn't really, does not really need to imply which member is affected. It's all done by examining the method parameters and checking which dependencies are really needed. So Flow3 also supports property injection, quite similar to Symfony, but as I said, just all in the code. So you annotate your talk service property with the @var annotation, which most IDEs easily use for the code completion part. So it's quite likely that you have that annotation already in place. And then you just add an annotation that's called Flow3 inject, which you need to import as you see in line 3 or 4 on top. So otherwise, the annotation would not be recognized by Flow3. So when the class gets created, Flow3 checks that, checks the list of the members, sees that the talk service needs to be injected, and then it would do the lookup. But as I said before, I would not prefer to do that because as you can see here, so you see in live code, if you watch top down from the class, you don't see that there is any injection visible, right? So you would have to open the class file, examine that, see which members have the inject method to understand which stuff gets more or less magically into your class. So if you have a setter, it would be visible from the outside. In this case, we have bound our talk service property to a talk service class. We can also bind it to an interface, as shown before. In this case, and I talked to Robert yesterday, and he said, if you have one interface and just one class that implements the interface, it will automatically use the correct object. It did not work for me. I don't know why. Maybe I did something wrong. If that doesn't really work for you, as before, you can define it in the configuration file. You're just going to simply say, anywhere we are dealing with our talk service interface, use that class for it. Obviously, that class has to implement the interface. Otherwise, some strange things will happen. So, and when I step back once more, so we would use the real talk service object that would get injected in the talk service, and we could access that. So Flow3 also supports scoping. In this case, we have 3 kinds of scope. We have singleton scoping, which would return always the same instance for the current request. We have the scope prototype, which would return a new instance on every occurrence. And we have a session scope. Now this is really interesting because if you set the scope to session, you share the instance across your complete session, right? So if you put something in or you change something in a session shared object, it would retain its state throughout the other pages. You set the scope on the class annotation by defining @flow3/scope, and just going to name which kind of scope handling you want to have or you want to deal with. Questions so far? Awesome. So that was just the broad overview of dependency injection and how it's done in different frameworks. What are the benefits? Why should you do that? Well, first of all, dependency injection allows you to deal with loose coupling. And loose coupling indirectly means that you can easily reuse your components in your own project as well as in different projects that you might be involved. It can reduce the amount of code just because you have all the configuration stuff either in a separate configuration file or somehow separated or distributed within the annotation parts in your class, right? So you don't need these 100 lines of creating new objects, wiring them correctly together so that you're able to deal with something. And always keep in mind that only deleted code is good code. So if you can get rid of something, it's quite nice because less bugs will appear. I think it really helps developers to understand the code because if you can grab a class from a framework or from an application you're dealing with and you can quite easily play around with it because it's loosely coupled, right? Just take the class and see how it reacts, provide some kind of mocked object so you can see how the interaction works. So it's quite easy to figure out how things work. It's actually what I have seen with our developers dealing with our own framework. So it's quite easy to get them, spot how different parts of the framework do their own work without having to look at the overall picture and trying to figure out from a top-down 10,000 feet view what's really going on somewhere. When we have benefits, we also have some cons, some negative points. Developers really need a mind shift, right? You don't have these new instances or these new operators back in the code, so it's probably quite difficult to understand really what's going on. You don't really see physically physically see the correct instances you are working with, right? You have always these interfaces in place. So it might be a bit confusing for new developers who are new to the paradigm to really get a feeling for that. Unfortunately, we are really missing a standard for the DI container up to now. As you've seen, each of the frameworks does its own style, which is really bad because you cannot really reuse that stuff in different frameworks. So you are more or less locked in a framework that when you do a choice right now. So when you've done an application using the Symfony framework, it's not really possible to migrate that to Flow3. It might be not that big of a case, but let's say if you come to a point in one framework where you can't really easily work around the different limitations, there is no really easy way to switch over to a different framework. This is also a really big deal, I guess. So we don't really have support for IDEs for these different frameworks. I never really thought this would be a big issue because we used to live without IDE support for our own framework for roughly 6 years. Until last year, I had to do some project with Spring Framework, and I used their IDE. And this is really insane. Like, you got code completion in the XML parts, and you can refer to classes in the XML files which are existent, which really speeds up development, right? So this is really something I miss, especially in the Flow3 framework when you're dealing with the annotations, because you really have no clue which annotations exist when you're new to the project. You have to deep dive into the documentation to figure out what that stuff means and how you could add it. So that really helps to have IDE support. Last year we had one of our students write a test IDE, let's say, as his bachelor thesis, so just as a proof of concept for our own framework. If you guys work with one of the big frameworks and think you need IDE support, especially for Eclipse, just going to talk to me. I would really happy to contribute that code to the community. Currently it's right tied to our framework, but I guess we can find some ways to make it aware of the other frameworks. So that just was a broad overview of DI and how it's done in PHP. Personally for me, it's great to see how far we have come. But there is still a lot of work to do, I guess, to get really good basis. And I'm really curious what we'll figure out next. So thank you. Oh yes, this is the joint-in URL. If you like the talk, rate it. If you think I completely fucked up, just going to rate it again. Anyway, thanks.
DPC Radio is a production of iBuildings. The materials presented are copyright of the speakers. This episode is released under a Creative Commons Attribution, Non-Commercial, No Derivatives 2.0 license. iBuildings is a full-service web development company specializing in PHP development. For more information on how we can help you with your next web project, visit our site at ibuildings.com. Thanks for listening, and we hope you'll join us again for DPC Radio.